Okay, so we're starting our unit on polynomials. So first we need to define what a polynomial is. A polynomial is a monomial or the sum of monomials. A monomial or the sum of monomials. So two things I can't have. I can't have negative exponents so x to the negative 7 or 1 over y cubed, those would not be polynomials. I also can't have fraction or rational exponents. So things like x to the 3/4 or square root of y, which is really y to the 1/2. I can't have things like that to be polynomials. Now let's talk about some terms. And if you have colors available, you can color code this. So when I have a number in front of a variable, that's called a coefficient. That little number is called an exponent. X is my variable. And then if I don't have a variable with it, it's called a constant. I would call this whole thing, oops, there we go. I would call the whole thing an expression, and each of the pieces would be considered a term. Now, if it had an equal sign, we would call it an equation. Like terms are when you have the same variables raised to the same exponents. So examples would be 4x cubed and 6x cubed, or negative 6x cubed. If I have two variables, I want things like 4x squared y and negative 7x squared y. So those have the same variables raised to the same exponents. There are different ways we can classify polynomials. The first has to do with number of terms. If I have one term, it's called a monomial. Two terms is called a binomial. Three terms is called a trinomial. And then we stop and we just say, if it's four or more, we say it's a polynomial of however many terms. So if it was 4 terms, I would say a polynomial of 4 terms. If it had 5 terms, I'd say a polynomial of 5 terms. We have a little more stamina when it comes to degree. If you don't have a variable, then it's considered to be to the 0 exponent, and we call that a constant. If the highest variable has a degree of 1, then we call that linear. If our highest exponent has a degree of 2, we call that a quadratic. And then cubic, quartic, and quintic. When we add polynomials, all we do is combine our like terms. These parentheses really are like having a 1 in front. And if I multiply by a positive 1, it doesn't change anything on the inside. So that means I can drop the parentheses and distribute that 1 as 2x squared minus 4x plus 4 plus a negative 2x squared minus 5x plus 4. And then I can combine like terms. So 2x squared and negative 2x squared, that would give me a 0x squared, so I don't need to write that. Negative 4x minus 5x would be a negative 9x. And then positive 4 plus 4 would give me a plus 8. Okay, so on the next one, I have a 1 in front, so if I distribute that through, it's really just staying the same. So 7x cubed plus 6x squared minus 2x plus 9x squared minus 4x plus 3. Now, my 7x cubed doesn't have anyone to go with, so he just gets brought down, 7x cubed. Then I have positive 6x squared, positive 9x squared, so that would give me a positive 15x squared. I have a negative 2x and a negative 4x, so that would be minus 6x. And then I have the plus 3 as a straggler. That's all there is to adding polynomials. With subtracting, there's just one caveat, which is your first parentheses, that's just a 1 you're going to distribute, so that will stay 2x squared minus 4x plus 4. But the next one is a negative 1. So when I distribute a negative 1, that's effectively going to change my signs. So this will become positive 2x squared, positive 5x, minus 4. So once again, that negative is being distributed and is changing all the signs. And now I combine like terms. 2x squared plus 2x squared is 4x squared. Negative 4x plus 5x is plus x. And then 4 minus 4 is 0. So notice I get different answers depending on if I'm adding or subtracting, so that matters. Okay, let's do the same thing below, and I'm just going to write this one above the problem since it's at the bottom. 7x cubed plus 6x squared minus 2x. And then we have a negative 1 that I need to distribute and change my signs. So this would be a minus 9x squared plus 4x minus 3. Once again, my 7x squared doesn't have anyone to go with, so it's just 7x squared. 6x squared minus 9x squared would give me a negative 3x squared. Negative 2x plus 4x would give me a plus 2x. And then I have a minus 3. The last thing we need to talk about is multiplying. Now, with the problem on the top, we could do FOIL, but I'm going to use the box because once we get to these really large ones at the bottom, we're going to want to use the box. So, if you haven't used the box before, it's basically an area model. So what you do is you count your number of terms. So in my first set of parentheses, I have 1, 2 terms. So that means the top of my box needs to be 2 across. And then my second parentheses has